Welcome to the studio. How are you doing?
We are doing
What's
well.
going on?
Hey, we got both of you. That's fantastic.
What's happening?
I'm so
Hey.
happy.
Well,
Welcome
Karol
to the
worked
show.
for Big Tech. You can ask him about how it was.
Yes. I mean, maybe that's a great way to start. We're huge fans. We were just singing Big Tech's praises, saying that we would do anything to support big technology. And yet you left Big Tech. Why did you leave, and what are you building now?
We are building physical intelligence. We want to build a model that can control any robot to do any task. This is something I did explore in Big Tech before. It's just much more fun to do it in a startup. Way more fun.
Also, a little quicker.
A little quicker.
A little
Yeah.
faster paced. Yeah, I mean, the pace has been
if
crazy.
anything's become clear in the last few weeks, we need the robots now.
Yes.
We can't really wait 20 years. And if Big Tech was, fully responsible, we probably would have to wait something like that.
Yeah, for sure. So can you walk me through the most recent announcement? I saw the video, fantastic, but how would you break it down in terms of like what the milestone represents?
Yeah, so the biggest challenge in robotics so far hasn't really been agility or dexterity, what the robots can do,
Yep.
but been generalization.
Yep.
Kind of similar to what we've seen in language before, where it was really, really hard to get it to do tasks where you just ask it to do something and see if it can work. And what we tried to do for the past 6 months or so is to get to the next level of generalization for these models for robots. So the challenge we set for ourselves is to take a robot to a completely new home it's never seen before and ask it to do a complex long horizon task like clean a bedroom or clean a kitchen. And there is so many details that go into cleaning a kitchen that you need to understand when you're in a new home. And you only start appreciating it when you try to do it with a robot, where everything is different. Like the countertop looks very differently. You don't know where the drawers are. You don't know how to open them. You don't know where the objects are. You don't know where
When I try to wash dishes in my house, I'm like, I can't, where's the sponge? I don't know where the soap is. Where do I put this? So,
It's a mess.
So not
you
even
can't
easy
generalize.
for me,
Yeah, I guess. Challenge for
really,
everyone.
really hard. And on top of like knowing all of those things, then you also need to connect it to motion. You actually need to get the robot to do the right thing. And it turns out that with Pi 05, which we just released yesterday, we can do that. And it doesn't work all the time. It's not that I can just give it to you and it will work in your kitchen every single time, but it works quite often quite well. So we bring it to a new home and it can do those things maybe like 50% of the time, sometimes 80% of the time.
Big increase from 0% of the time.
But yeah, big increase from what we've seen before, where the previous state of the art was basically if you want to show a robotic demo, you need to collect data in that specific environment for those specific tasks, and that's where you show it. But
Do you
now
think
we
that-
can, for the first time, bring it somewhere else, and it kind of works. It understands what it needs to do.
Do you think that consumers will generally be more patient around reliability with robotics? Because if let's say I have some type of robot in my home and I say, hey, do the dishes, right? And 50% of the time it does it perfectly. And the other 50% of the time I have to kind of interject. Whereas if I'm like booking a flight and only 50% of the time it like books the flight, it's like, well, I'm just going to do it myself, right? Because like it's only going to take me a minute, whereas like the dishes could take 20 minutes, right? So how do you think about kind of the sort of threshold of reliability in order to like really deliver value for consumers?
Yeah, I think that like we don't think right now about delivering value for consumers, and it's
Right.
kind of why we structured the company the way we did. We're a research lab. We're trying to solve this problem of physical intelligence. We really like these consumer-oriented tasks, and I think people tend to as well, like when they think about laundry being folded for them. I think there'll be a point at which it gets good enough that we can deploy it to consumers, but it's not going to be like 50%. It's going to be closer to 98, 90, 99%. And there, I think we can harp on self-driving cars, where there will be a period of interventions, right? Like if it doesn't work, it's not that it just will stop and do nothing for a while. We could have a human teleoperator intervene and finish the task. But I think the other cool thing about the home and consumer use case is there's so much that could also just happen overnight. There's like while you're sleeping, your laundry is folded, your meals are cooked for like they're prepped for the week ahead. Your house is tidied. So consumers still a little far away, but making a lot of progress.
Can you talk about the just the path in terms of the underlying technology to go from a Roomba. We're pulling up the video here on the stream of what you've actually built. What were the foundational turning points in terms of the different models and different breakthroughs? I imagine the transformer was really important, but there's probably a ton of other developments that excited you. And now is the time, like, we're ready to go.
Yeah, there's been a lot of things that we are building on top of. Things like transformers, things like vision language models, the concept of pre-training and post-training. A lot of those things transfer to the robotics world, but they're not as well understood. We are still in the process of figuring out what that recipe should be like. We kind of have to rediscover some of the steps that language people had to do initially and see how we can map them onto the robotics world. We don't have the privilege of having an open internet full of data.
Yep.
We need to collect that data ourselves, which on one hand is a big challenge. Like, the data isn't there. You can't iterate nearly as fast. On the other hand, it also gives you more freedom in figuring out what kind of data is the most important and what data to collect. For this particular Pi 05 advancement, what we had to do is, one, collect very diverse data set, large diverse data set that involves not only model manipulators in homes, but also static robots in the office or data of the internet. And it turns out, if you collect very diverse data across many different tasks from many different form factors, they all contribute to each other. And they contribute to a better understanding for the model of what actually is happening and how to utilize all of the data to figure out what to do. So that was a really, really big component. And then there's also a lot of architectural things, a lot of details that we need to get right to make sure that we take full advantage of that data. Interestingly, most of the data is actually not the model manipulators in many different homes. It's a very, very small percentage of it. So it gives us also a lot of hope that we can leverage the data from the internet or from other platforms where it's easier to collect it to get to that kind of generalization.
Can you talk a little bit about simulation, like data generation through simulation? I imagine it's very easy to procedurally generate like 1 million different floor plans or 1 trillion different floor plans to try and navigate those in, kind of 2-dimensional space. But at the same time, when you get into the manipulating of a sheet, all of a sudden that's a physics calculation. It's probably harder to simulate. It's not like with self-driving cars, there's, Grand Theft Auto you can train on. I haven't, maybe there's a game where you clean up your house, but I certainly haven't played it. How effective has simulation been in generating data, and is it useful? Is that a viable path here?
Yeah, it's been so far really, really useful for locomotion, for robots walking around.
Yep.
And the reason for this is that for that kind of problem, the main difficulty is modeling your own body. Like, how do you place your foot? How do you walk? And that you can do once when you model your robot really, really well, and then it works. It works across many different terrains. You can easily randomize that and figure out the gait that is robust. It hasn't worked nearly as well for manipulating objects, for working with your hands. And I think the reason for that is, then the difficulty isn't about like how do you move your hands, it's more about the world that you're manipulating. And that is much harder to simulate. You don't just do it once. Like, every object you interact with is different, and you have to model each one of those. And it's really, really hard to figure out all the different physical parameters to make it good. So this is kind of the data that is the most important, the data of physical interactions, because this is the data that is not on the internet. This is the data that is not even described in language. This is something that comes really natural to you. You just know how to do it. You don't even sometimes know how to describe it in words. So I think it's kind of like a really bad combination where it's the hardest thing to do for sim and is the data that we need the sim the most for. And what we discovered so far is that basically looking at the past successes of machine learning, of AI, it seems that the best successes are where you take real world data and large diversity of that data and learn directly on that. You don't try to find some kind of proxy or some kind of simulated environment that reflects what you actually want to do. You just go after the problem head on. And that's what we're doing here. So we're collecting a ton of data ourselves in the real world. We can collect very diverse data this way. It's also very easy to collect it across many different scenes, many different objects. We don't need to, create them in sim. We can just buy them and bring them in and start interacting with them. And that so far has been actually easier than we had initially thought.
Yeah, I mean, you say you're collecting a lot of data, but I imagine like there's only so many of those robots in that demo video that you can manufacture. There's only so many houses that are like, yeah, come try your 50% robot in my house. Is that a key? Is that scaling as you'd like, or is this more like you're going to build a physical, demonstration unit, and then be manipulating it in a warehouse, or is the plan to be more like, let's roll this out and just have beta testers kind of dog food it for us?
All of the above.
Okay.
Basically, where we find there's benefits to scale at this stage, we'll scale it. We'll figure out a way. And whether that's producing more robots, giving them to people, whether it's scaling up our operations team and the folks that teleoperate these robots ourselves, whether it's going out and commercially deploying these into environments where they're doing economically useful or viable tasks as a training data set collection, we'll do it. We also think there's so much, though, to do on just the algorithmic development that can make the data far more useful, that can reduce the necessities of scale, but we're structured such that we can go and pursue every avenue required.
That's awesome.
Would you guys both mention there is that was one of the big questions before Pio 5, where it kind of was unclear, do we have to visit a million homes? Do we have to visit, hundreds of thousands? And at some point it becomes kind of not feasible or really, really hard, and maybe we need to find a different path. But so far, we've been quite surprised by how few different environments you need to see to be able to generalize to a new one.
That's awesome.
We actually got really reassured that this path could really work.
Would you guys like to see way more early stage like robotics companies? It feels like there's, the Optimus, the 1X, you've got, Figure making noise. But it feels like, we just covered this, I think, Monday, the Chinese humanoid marathon. I'm sure you guys followed that. They've got a lot of people working on this problem. It seems like there's a tendency in venture to think that, okay, there's a bunch of heavily funded players now. I shouldn't go build in that space. But at the same time, when you look at some of these TAMs, maybe we should have 10 times the amount of, early stage robotics companies getting started.
It's extremely early. We work with, I'd say, probably most of the new robotics companies starting in the US and abroad. If you're starting a robotics company, reach out to us. We'd love to work with you. You can build the body, we'll build the brain. But yeah, we need to see a lot more robotics companies, particularly in the US.
That's awesome. I want to talk. Did you ever interact with the Google Arm Farm?
Yes. Yeah. One of my co-founders actually started that project.
I had a feeling. Do you have your own version of an ARM farm, or can you describe for people that might not know what was the genesis of the ARM farm? What was the purpose? What was the takeaway? And is that does every robotics company need an ARM farm, or is it just you? Or and what will that look like in the context of what you're building specifically?
Yeah. So back then, that was a few years ago. The idea was that for robots to learn to acquire those kind of skills, to manipulate the world around them, you can't really prescribe it. You can't just code it all up. The world is too diverse. You can't, have a lot of if statements describing what you should do in every single situation. They need to learn it the same way as we do. And the idea of the ARM farm was to set up many different stations where you have static robots, static robotic arms, where they just practice and they learn from experience. So in that particular case, they were trying to learn how to grasp objects. So they just had a bin in front of them with lots of different objects that are very diverse. And the arm was just going down and trying to figure out how to grasp it. And over a long period of time, it gathered enough experience to actually learn from it and become really, really good at grasping objects, like remarkably good, and way better than any kind of prescribed systems that people design by hand. And on one hand, it was a big success because of that, because it was clear that this learning approach is something that can truly work and understand the nature of grasping and truly nail that skill. On the other hand, it was also disappointing in that it took really long time. It needed a lot of data, and especially a lot of data at the beginning was kind of just like the arm wandering around and not knowing what to do. So it seemed like a lot of that time was just kind of wasted with the arm figuring out the simplest things.
Mm-hmm.
And one thing with Pi O5 that we are really excited about is that we are now at the stage where the robots kind of get the sense of what they should be doing in the environment. So they are no longer in this space where, you just like arrive in a new home and you start with just like moving your arms around, not knowing what to do and hoping that you do something that is useful, and then you learn from that. You start at a point where you kind of know more or less what you can do. It works some of the time. You just now need to get it to work every time and really, really well.
Can you talk about the path to, or the importance of end-to-end learning in the context of robotics? My understanding is that teleoperation is great, and as long as it's economical, we should do it. And then having a deterministic code, control system that's written in C++, that's also great as long as it works. It's sometimes more debuggable. But the reason that we want to get to end-to-end AI systems is that then you're on the scaling law, then you're just data bound, and the more you can manufacture, the more you can produce the actual robots. You're on this flywheel, and you're now bound by actual productive, like getting the cars on the roads, getting the robots into the world. That will naturally create a flywheel. That's what everyone's hoping for in self-driving. But what does that path look like now? And how ridiculous is it to claim that end-to-end robotics will be here by the end of the year or something like that?
So end-to-end robotics is already here. Everything
Okay.
we've shown so far is fully end-to-end, where you take camera input in and a few other sensors and output actions directly.
Wow.
I think there's another reason to do end-to-end learning, which is this is, I think, the only thing that has a chance of working.
Yep.
But like if there was a way to just pre-program your robot and write a really good C++ code to get it to do all kinds of different things, like folding laundry, we would have done it a long time ago.
Totally.
That's not for the lack of trying. Many people have tried it for a very, very long time.
Yep.
There's just, the world is too complex.
Yep.
There's too many things that you will never see, you will never predict, and you can't really write that code. And I think the only way to get there is for AI to figure it out from experience. This is similar to what we've seen in language or in vision, where people have tried to write chatbots with writing different instructions and prescribing logical steps of how you should proceed. But it turned out that the intelligence you need is much more messy. It just like you give it a lot of text and you let it figure out all the different patterns and analogies, and there's many, many more of them than the ones that we can express in code or in language. And I think something very, very analogous is going to happen here, and that's what we start seeing. Like the demonstrations that we've shown so far here at Physical Intelligence are of tasks that were not possible before, like things like folding laundry. You can't really, there is no program that I've ever seen that could do that. The same with arriving in a new home and making the bed. There's just too many variables there to do it any other way.
Can you talk about some of the experiences that you both have had in your careers? Google and Stripe, in some ways big companies that maybe move slower than a small startup, but at the same time, both of those organizations, I feel like the time from, hey, we're starting the company, to we have a product, that it wasn't a research organization for years. What have you learned from those organizations? What are you taking into this experience?
Stripe really taught me everything I need to know about building a robotics research lab. It's just lessons galore. I'd never worked in a research environment, so I don't have priors. I don't know what a research environment actually looks like. I just know what our research environment looks like. I feel like whatever it looks like, maybe it operates exactly like startups, like maybe grad programs are exactly like startups, but we feel like every other company I've worked with that moves extremely quickly and has a clear set of goals and direction, and just has a bunch of people that work behind it and work extremely hard to solve whatever it is that we're setting our minds towards. And there's so much I learned from Stripe that informed that, but a lot of it's just the obvious stuff, right? It's like hire exceptional people, set a really high bar for it, don't compromise, set a very clear set of goals for everyone, really align people. Actually, I think that's one thing I really took from Stripe is you want an extremely aligned set of people. And I've never seen more alignment than I've seen at Pi. We talk about the alignment tax. Like when we're bringing someone on, how much work is there to align them around our mission, our way of seeing the world? And almost everyone that joins, there's like basically nothing. Most of the people that work here have dedicated their lives towards robotics or robotic learning or AI in some form or another, hardware, whatever it might be. And that just allows us to move so much quicker. It's like we need to communicate a fraction of what the average company needs to communicate to someone. We don't really need to inspire people or motivate them because they're so inspired and so self-motivated. I think that's probably one of the things that's worked best for us today.
How have you seen your customers react to all the news and chaos around the tariffs? I think a lot of these companies are not in full commercial production yet. So it's not like, hey, we're no longer making money, but how are they thinking kind of like long-term, just given how much of the supply chain is based in Asia? And are there opportunities for, new US kind of like subcontractors and manufacturing companies to sort of service this new industry?
Yeah, the good thing is, I mean, good and bad. It's also subscale right now. Like most of the money is being spent on R&D rather than scaled production, and so it's not as if there's 100,000 robots that everyone's buying, and it's now just twice as expensive. I think the good thing is that given it's subscale, there's a lot of time to build out U.S. supply chains, and it's putting a lot of focus on figuring out, can we get U.S. actuators? Can we start to create companies that are developing those and all the other critical supply elements of the supply chain. So it's actually just getting people into gear, and maybe it's the right time for it.
Can you talk a little bit about what you're excited about on the data center side? Is there a moment where you're like really pulling for Stargate to come together and we need the 100 gigawatt data center to crunch, all of the data that you've collected in, kind of a GPT-5 class training run? Or is that something that's like so far out that you'll always be able to just, tag along on the residual capability from the large language model labs?
Yeah, we are not there yet in terms of like having a full scaling law the same way as we've seen for LLM companies, where you can just translate compute to progress or compute to capability. We are searching really heavily for that. We are trying to figure out what is the recipe that would scale like this, but we are not there yet. We do at the same time generate a ton of data. I think that's one thing that I realized since starting the company, is that robots generate a ton of data, and you don't need that many to generate data that is close to the levels that LLM companies use for their models. And there is no ceiling to it, right? It's not that we're run out of the data that the robots can collect. It's not like the internet. So I think over time, it's quite likely that the places are going to switch a little bit, where most of the models, including LLMs and VLMs, are going to be using real world data collected through robots, because that's the data that has no ceiling and it's very active, as opposed to just passive observations of what people wrote on the internet. And I think at that point, probably the question about data centers and compute is gonna be a big one. But for our models, we are not there yet. We are not bottlenecked by, if only we had 100 times more compute, everything would have worked so much better.
Yeah. How do you guys think about demos long term? We joked on the show recently after seeing the Chinese humanoid marathon. Like, I want to see humanoids doing like big wave surfing, cliff jumping. At what point is that like worth even doing or exploring, just because of the amount of attention that it would bring to the industry?
What do you think we should demo?
I think I'd like to see one of your robots surf Jaws. I think that's really.
I was saying
that's
I want
AGI
to see a robot do the 900 on a half pipe, Tony Hawk style. That was a really foundational moment in my childhood and American skateboarding.
Like
culture.
Really life or death stuff.
Exactly. It's got to be high stakes.
Yeah.
What about with hands? What about manipulation?
Juggling for sure. Rubik's Cube for sure. Juggling Rubik's Cubes. You can do that. I can do the Rubik's Cube. Jordy can juggle. We need to learn each other's skills so we can do both at the same time. But yeah, I mean, these stunts, when they're done right, they can draw a bunch of attention. Although you guys have plenty of attention. I don't know if that's really what's keeping
but it's
you
an
back.
interesting thing where it's like you have the intention of the entire industry, but then at some point, you need to basically inspire the next, however many thousand robotics companies.
I would love to know about obviously with any AI project, there's always the public perception of like job displacement, dystopia, AI doom, etc. But when I look at the demo that you just posted, I'm like, that thing is going to be fighting on my team in the Singularity. Like, this is a friendly robot that will be defending me. But how do you think about the like tuning the language interaction so that do you see a world where yes, it's doing my laundry or making my bed, but if I happen to just also ask it, hey, tell me about the news, I can just have a chat with it. Is that something that's even in your mind in terms of like human computer interaction?
It's not a big focus of ours right now. We're so focused on manipulation and economically valuable tasks, and more so than that, the fundamental building blocks that we think gets us from here to physical intelligence. I think it's inevitable that everyone has robots in their homes, their workplaces, just like in their lives. And I think they'll want robots that are more useful than just doing things, whether it's companionship or like it's the best Amazon Alexa that can actually then go like cook the recipe that you ask it for. It's a place we focus around the interaction, but right now it's more understanding the intent of clean my kitchen and then breaking that down into tasks. But it's pretty straightforward to go from do the thing to tell me about the thing to let's have a conversation about the thing. And so it's on the horizon, but not the greatest priority.
And one thing there I would say is with the models we've been releasing, they're actually built on top of vision language models. So these are the models that are truly what they call multi-model, where you can talk to it, you can ask it what they see in the image, and every now and then you can ask it to perform actions too.
That's cool.
And what we start to realize is that all of these different data sources contribute to each other. They give you just like a bigger picture of what the world is like and better understanding. And it just turns out that robot actions is just like yet another language that these models can speak. And they just need to learn it and see enough examples of it. So the model that we have already is the model that you can talk to, and it works, just as well as open source VLMs. But on top of that, it can also have that understanding be very embodied, and it understands what it sees in front of it, and it's a much deeper understanding when it knows how to move its arm to actually accomplish a task.
We were kind of joking before the show about the obvious comparison between robotics and self-driving cars. But can you explain to me, like I'm a 5-year-old or like a venture capitalist, like why is that a bad analogy? Why don't you love that that analogy?
I feel like it's not that you don't love it. It's just that it can put you down a bunch of wrong directions. There's a lot of parallels, but I mean, even like the Waymo Tesla thing, right? Like Tesla has this incredible advantage with how much data they're collecting and passively, yet Waymo is so much better so far, and it has so many fewer cars on the roads. There's useful things about it, but there's also aspects that don't transfer in the analogy. And I think the reason why we were joking about it is it's the number one question.
Yeah.
We don't talk to many 5-year-olds, but like investors and VCs ask us. And so we have to go down this rabbit hole where we're breaking down all of the assumptions and correcting some of them and validating some of them.
I mean, is that so should VCs, if they're looking at the robotics market, just throw out that analogy entirely? Or should they be saying like there are a set of robotics companies that are in the Waymo category and there's a set of robotics companies that are in the Tesla category, and those are reasonable, like an ontology to map to?
Yeah, no, there's a lot of very useful stuff in the analogy. I think I think one thing that's interesting is that there are all these self-driving companies that have died over the past 15 years. And one thing that we actually like to remind people is that this is not coming tomorrow. You log on to Twitter and you'll see all of these crazy robotics demos, most of them teleoperated, or most of them being like robots doing backflips, which is a much easier problem than actually a robot folding laundry. And the thing we really try and remind everyone that looks at investing in us or is thinking about investing in us is this is not a problem we're going to solve tomorrow. There's fundamental research breakthroughs that we need to make. And much like self-driving had it's like a 15-year arc at this point, there is a very high likelihood that robotics is the same way. Like we think our greatest competition is science itself. It's not like this company or that company. It's just maybe we can't pull it off in our lifetimes. We think we'll be able to. It's looking more and more likely, but it's not a tomorrow thing.
I have one last question. I know you enjoy food and cooking. What is the final eval, the Mount Rushmore, the Mount Everest of cooking that you expect will be the last dish that a robot will be able to cook? What's the hardest dish for a robot to cook?
The Don-Angie lasagna.
Oh yeah?
Yeah.
Okay.
It'll be very difficult.
So when they cook that,
We're
AGI
done.
achieved.
It's
We're
game over.
done.
Yeah.
It's game over. That's amazing.
Amazing.
There was actually a
final
recent
benchmark.
AGI benchmark. Someone shared a screenshot, and it was a very old definition of AGI. It said it'll be able to describe a sheep, tell you 3 things that are larger than a lobster, and AGI is here by that definition. But one of the things that it can't do is bake you a cake. And we just thought it was funny that like that was the last thing that the computer can't do. But maybe soon, maybe future. But thank you so much for coming on the show.
This was great.
This was a fantastic conversation.
Thanks for making the time,
Best
guys.
of luck to you, and thank you so much for building this. This is really important technology.
Yeah, we're excited. Put a robot in the studio when you're ready.
Send it
We're-
over.
we
It's
got
a mess. I
plenty
have
of
clothes
tasks.
all over here that need to be folded. So we'd love to have one.
Awesome. See you
Here's a
guys.
live demo.
See ya.
Bye.